So in this lab, I'm going to divide this into two parts. I'm going to create a reliable access to the internet using OSPF and default information originate command. So to accomplish that, in my design, R1 should be primary gateway towards the internet, and R2 should become the gateway of last resort only if R1 has trouble accessing the internet. So let's start with the basic stuff, which is the default routes and distribution into OSPF. So on R1, I need to create a default route with the next hop 10.1.10.254. On R2, the next hop will be 10.1.20.254. However, I need to ensure that R1 is the better or more preferred gateway of last resort than R2. This can be accomplished using the introduction of the metric difference in metric between R1 and R2. Let's do that first. So what I'm going to do here is I'm going to create a default route 10.1.10.254 and introduce that into OSPF via default information originate command. So if I just go back to R3 right now has no default route, so show IP route 0000. However, if I go ahead and say router OSPF1 default information originate, I don't need to use keyword always originate because I have a default route configured statically here. So if I do that, let's observe a few things. First of all, why is it even working? Let's just consider that. Let's verify. R3 knows how to reach the internet. If I use PC2 down here and try to access one of those prefixes on the internet, so let's say ping 100.10.0.1, I should be able to do that. Okay, and the trace should go 100.10.0.1. It goes through router 3, which is the default gateway for this network here. It goes to router 1, so router 3, router 1, and goes towards the internet 1 and to the internet. Now, why does it even work? So the command, let's go backwards. Show run section router OSPF. This command originates default route into OSPF. It redistributes a static default route once it's one configured here. And the one is configured here with this command, which creates this entry, show IP routes static. So as long as this entry exists in the routing table, it is going to be redistributed into OSPF with this command. So this command created the default route, and obviously the router needs to know which is the outgoing interface. So as long show IP route as the next hop is reachable in the routing table. So we're performing route reverse lookup here. As long as this entry exists in the routing table, so next hop is reachable, this default route will be introduced into OSPF. So this one is actually in the routing table, pointing to the outgoing interface Ethernet 0/3.10, which is this interface right here. So as long as this interface is up, as long as the layer 1 and layer 2 is up, all is working. One last thing I want to check here is what is the cost introduced by default when we use default information originate command. Do show IP OSPF database. This one is introduced as external type 2, so I'll go for external. And the OSPF introduces, so on 1111 router, we introduce the default route, which is the all zeros with a mask all zeros, and the metric is 10 by default. So now if I do the same thing on R2, I need to ensure that the metric is higher than 10 introduced into OSPF to make R2 the backup gateway of last resort. So I'm going to repeat the same thing. Conf t. So first maybe I'll do IP route 0.0.0.0.0.0.0 pointing to 10.1.20.254. So router OSPF 1 default information originate, and I'll add metric value 20, which is higher than on R1. On R1 we had metric 10. So do show IP OSPF database external. Now what we see is there are two routers advertising default route 1111 default route mask 0 metric 10, and router 2 same default route mask 0 but metric 20. So still, if I look at the show IP route command here, the next hop is 10.1.13.1. So this already is working as expected, but there's one problem we introduce into this picture. Default route exists on R1, so we have this do show IP route static, and as long as this route exists, it's going to be introduced. But if I have a problem with that interface and this interface goes down, let's actually make that happen. So interface 03.10 goes down, shut. What should happen is that now R2 is the only one introducing the default route, because this one is gone from the routing table. It's no longer there, and as a result of that, this command this command here won't originate default route. One is gone. So the only one now introducing the default route should be R2, which is probably happening. So let's go to R3 one more time and verify who's the next hop. The next hop now is 10.1.2.4 for default routes. So things are still working, so PC2 can still do the trace to the internet, but it uses different path through R2. And it's working. That was obviously ARP request here, so if I do this again, it works. If I bring this back up, metric on R1 is more preferred, so if I do no shut, let's wait for this to happen. So now if I go to R3, if I do show IP route default route here, R1 is back again my best path, so PC2 prefers the previous path through R1. And all good. However, what if the problem is not local on R1 but local on internet one? And what if this interface goes down? There's a switch in between them, so R1 still has the interface up and default route is working from its perspective and is being introduced. Let's bring the internet one here. So first of all, no login console, so we're not interrupted with some messages here. If I go interface E03.10 to do show run interface E03.10. So what if the failure is not direct on R1? So if I do shutdown on this end, R1 will no longer be able to ping. So let's just do this. Do ping 10.1.10.254. Even though it cannot ping it because the problem is on the other end, on the remote end, now the default route is still being generated. Do show IP routes static because its interface is up. It's up and running. So how do we solve that problem? Since this video is getting too long, I'll introduce this problem solution in the next lab, which will be using IP SLA and tracking objects.